All right, we have started the recording. Okay, so we'll be continue on sketching of trigo graphs. Now we'll be looking at work example 6 on your textbook. Work example 6. Okay, so very important for you all to know how to sketch the graph because your sine, cos, and tangent graph will be tested. Okay, it's either a 3-mark question or a 4-mark question. In fact, the recent papers all have been testing one of these graphs lah. Okay, so you all learn quadratic graph, cubic graph, sine, cos, tangent, exponential, log. Okay, so you all need to know every single one of this. Okay, so let's look at this question first. Fx is equals to 3 sine 2x for 0 degrees to 360 degrees. So things to take note is, number 1 is the equation. Number 2 is your range of values. Okay, so they say 0 to 360 degrees. So you all got to follow where the range of values of x, where they want you to draw until, from where to where. Okay, very first question. Write down the period of f. Okay, so we just need to follow the formula. Period of f for sine and cos would be 360 degrees divided by the b value, which is this value. Okay, so you're going to remember the formula. So how do we find period? It will be 360 degrees divided by 2, which is 180 degrees. Just a recap, what is the definition of period? Period is when it completes one full cycle. Okay, so your sine graph, one full cycle is like a S shape like that. Okay, it starts from 0. So within 360 degrees, right now, it completes 2 full cycles. Or another meaning, another way to understand is that if my period is 180 degrees, means it takes only 180 degrees to see one whole full sine graph. Understand? Okay, period one full cycle. Okay, second one. What is the amplitude? Definition of amplitude is, we look at here, the A value. Okay, original sine graph, your amplitude is 1 and -1. Okay, your maximum and minimum point is 1 and -1. So your amplitude is 1. How the A value, the 3, will affect the graph is that you multiply your maximum and minimum point by 3. Okay, so you got to remember this. Amplitude, so 1 times 3 now becomes 3. Okay, so you need to remember here, amplitude, follow the number in front, the coefficient in front. Period, you see the, the value to the angle inside, the 2x. Okay, the 2x, that one is the angle. So when we express trigo that time, it's all in angles. Okay, question C. Now, write down the coordinates of the maximum and minimum points of the curve. So, how do we know what's the maximum and minimum point? To be honest, normally I would sketch it out first, then it will be easier for me to see lah. Okay, but what you need to know, okay, for this, maximum and minimum point, always base it on your original graph. So your original graph, right, your original sine graph, it looks like this. Okay, these are the main points, like that. 0, 180, 360 degrees. Then your maximum point was 90, 1, and your minimum point is 270 degrees, -1. Okay, so you need to know at least this graph. Y, this is how your y equals to sine x graph. Okay, so as you all see in your textbook, you see what they list out? They list out the values based on this graph. So you see, y equals to sine x has maximum has its max and minimum points at where? Okay. We mentioned 90 degrees, 1, 270 degrees, 1. Okay, if you all see, right, how come they expand it to 450 degrees, 1, and 630 degrees, -1? Basically, what they are doing here is they are expanding this one. Okay, they're expanding one more cycle. Why? What's happening here is that originally, because your sine graph, it keeps going on and on, right? So what it's doing right now is that later on you need to fit 2 cycles within 360 degrees. Okay, because sine 2x. So how do we find another cycle? Actually, very simple. For the red color values, how do we know what is this value and this value? All you need to do is 90 plus 360 degrees because it's the next cycle. And every cycle or every period is 360 degrees. Okay, so you see 90 plus 360 degrees, you get 450 degrees, 1, which is here. Okay, 450, and 270 degrees plus 360, you're going to calculate and see. You get 630. 630 degrees, -1. So here is actually 630 degrees. Okay, so this is based on the original graph first, which is y equals to sine x. But now, we want to base it on 3 sine 2x. There are 2 things going on here. Number 1 is the period. So now my period becomes 180 degrees. Okay, everything is divided by 2, your x value. All of the values are divided by 2. And second thing is your A value. Your amplitude is multiplied by 3. So if you were to sketch the graph out, right now, this graph, how it will look like, I am fitting 2 periods, okay, 2 complete sine graph in 360 degrees. Imagine, this is, I always like to imagine like it's a spring like that. Okay, now this spring being tightened already. Okay, you can expand this spring, you can squeeze the spring together. Now at a same amount of space, I am trying to put two times more the length of the spring. Okay, get the illustration? Okay, the spring. So if I were to compact this spring, what will happen is that it will be very tight. Okay, so now it will look like this and like this. Okay, so this is within 360 degrees. So to achieve this, what needs to happen? Your degree also, your angles all will be divided by 2. So you see, originally the 90 degrees, what will happen? It will be 45 degrees. So here will be 45 degrees. Okay, then you see your next one, the original minimum point, which is 270 degrees, also need to be divided by 2. So it will be 135 degrees. Then your next maximum point, which was 450, will become 225 degrees. And your last one, 630, you divide by 2. For your last minimum point, it will be 315 degrees. Okay? So that is for the 2x value. That is what you all need to understand about the 2x value. Okay, now my period becomes half of it, so all my angles also become half. Okay, because 360 degrees divided by 2, now my period is 180 degrees, means I need to draw 1 full cycle of sine graph in 180 degrees. All right? Okay. The next thing is that we need to look at the A value, which is the 3 in the 3 sine 2x. So what happened? Originally, it was 1 and negative 1. Right now, you just need to multiply 3 and multiply 3 for the top and your bottom, your maximum and minimum point. Okay? So how do we do this? Hence, okay, hence, fx equals to 3 sine 2x has, okay, max and minimum point. Okay, which one was max, which one was minimum? So your max is actually the 45 degrees and 225 degrees at 3. You'll see here. This is your max. Your min will be here. Okay? Okay, on this sketching of graph. Okay, so two things are, this one we haven't introduced the amplitude, the shifting of the graph yet also, the vertical transition of the graph. Okay, so this one we only focus on the A and the B value, how it affects the graph. So write down 45 degrees, 3, 135 degrees, -3. Okay, so you see your 450 degrees, what happened? Also divide by 2, so it will be 225 degrees 3 and 315 degrees -3. Okay? Cool? All right. D, okay, D is this lah. Okay, they say sketch the graph of y equals to fx. So this is your graph lah. Okay, y equals to 3 sine 2x. A short recap again. Draw the original graph first, y equals to sine x. Sine 2x means you have, now your period becomes 180 degrees. Okay, they want us to sketch from 0 to 360 degrees, means I will have 2 cycles of sine graph in 360 degrees. Okay, for me to complete 1 cycle, it is 180 degrees. The next thing, the A value, which is the 3. In fact, there's no order to it. You want to do the amplitude first also, is fine. The A value, 3, will just affect the amplitude. That's all. Okay, 2 things only that's going on here. Okay. So question D, done. Okay, I want you all to practice how to draw. So follow through. Okay, the last question. Use your answer to part D to sketch the graph for y equals to 3 sine 2x plus 1. Okay, so now you got A, B, and C value that affect the graph. Okay, if you're unsure what I'm referring to the A, B, and C is the page, you all refer to the page 199. Page 199. A affects the amplitude, B affects the period, C affects the vertical translation, meaning it shifts up or shift down. So now we introduce the C to it, plus 1. Okay, so what will happen here? Okay, what will happen here? Means this whole graph, right? Okay, this whole graph, okay, let me put it here. It will shift up by 1. Okay, plus 1, -1 is your vertical translation. Vertical means this direction, in your y direction. So whether it will shift up or shift down, depending on you plus or minus it. Okay, plus 1 means all your values will plus 1. Okay, your entire graph shift up by 1. Okay, there are 3 main points that you all need to take note of. Your minimum point, your maximum point, and your midpoint, which we call the principal axis. So don't forget the midpoint also. Okay, teach you all easy way to do it, but because this I got technology to write, so it's easier. What can happen? This entire graph Okay, this entire graph will shift up by 1. So what will happen here? Your 3 will become 4. Okay, that's for your maximum point. Your principal axis originally right now is 0. Okay, it's 0. So what will happen? It will become 1. Okay, so don't forget that 1. And then your -3 will go to -2. Okay, so I'll just write over it so we can compare. So 3 will become 4. Here will become 1. So we draw this. This is now your new, in a way, the midpoint. And then here is -2. Okay, so follow this red color one. Now it becomes, yeah, okay, not so nice. Up, down, up, down, up, like this. Okay, not the nicest, but y'all should, it should intersect lah. Okay. So now my whole graph is shifted up by 1. This is y equals to 1. Main thing is that you all need to just know how the A, B, and C values affect the entire graph. That's all you all need to know. Okay, and you all have to be very, very clear on this, because later exercise 9.4, you all need to practice all of these graphs. Okay, all of these graphs. In the case that you all are unsure, okay, if you are unsure, now there's the software that I give it to you all, desmos.com. You all play around with it. Okay, just go and type in, like, let's say sine x. Okay, if you're unsure, okay, how does sine 4x affect the graph? Then you type in sine 4x, immediately the graph will be sketched already. Okay, so that's all you need to know. Okay, let's try one more example. Okay, wait, any questions here? All okay? All right, so we did for a sine graph, how the A, B, and C value affect the graph. A will affect the amplitude, B will affect the period, C will affect the vertical translation, which means your graph shift up or shift down. Okay, so this is work example 6. Okay, let's go to work example 7. Work example 7, page 202. Okay, page 202. Okay. On the same grid, okay, this kind of question, most likely they will give you all like a graph paper kind of diagram for you all to draw on it, because we might, if we do like sketching only, we might not draw it very accurately. The purpose of this question is that they want you to find the point of intersection between two graphs. It's like simultaneous equation like that. Okay, where two equations intersect with each other. All right, and how do we cause it to intersect with each other? The point of intersection is by doing simultaneous equation. Okay, so now we just draw it out. Okay, instead of go and calculate for these values. Okay, I don't think they're not asking you to count for the answer, but to just find how many solutions are there or how many roots are there. Okay, let's look at question A first. On the same grid, sketch the graphs of y equals to sine 2x and y equals to 1 plus cos 2x for 0 degrees to 360 degrees. Okay, two graphs. Let's put the first one green color. Y equals to sine 2x. Second one, we put it in orange color. Y equals to 1 plus cos 2x. Okay, 1 plus cos 2x. Okay, I give you all 1 minute. try sketching it by yourself first. Just roughly sketch. Okay, just roughly sketch it first. Then you'll see mine, see is it the same or not. Okay, y equals to sine 2x, and then y equals to 1 plus cos 2x. Okay, let's look at the first one. Y equals to sine 2x. The only thing that it has over here is the sine 2x, which is your period. Okay, your period right now would be 180 degrees because 360 degrees divided by 2. Okay, another way how I see it, but this works only for a whole number. 2x, right? What does it mean? It means I want to fit 2 cycles within 360 degrees. This only applies for sine and cos, not for tangent, because tangent, the period is different. Okay, so how do I see it, right? 2x, my original period is 360 degrees. So what I want to do right now is fit 2 cycles of sine in the same amount of space, 360 degrees. If 3x means I want to fit 3 sine graph in 360 degrees. 4x, 4 sine graphs within 360 degrees. Okay, so this is another way to understand it. Okay, but this is for fast sketching. You want to draw like the exact points, then maybe you want to try not to use this and count the exact angles also. Okay, so let's just sketch it out first. Okay, wait, let me write down the angle first. Okay, the main angles is 90, 180, 270, and 360. Okay, we only want until here. Okay. Okay, they will go up here. Go down. Up. Down. Okay, 1 and -1. Okay, so sine graph. Okay, so this is your y equals to sine 2x graph. Everyone clear? This how to draw it? Y equals to sine 2x graph. So all my angles you see is also divided by 2 as compared to the original graph. So you all always have to sketch the original graph first, or yeah, as in you need to know it at the back of your head how the original graph looks like. So you can always sketch out the original graph. Okay, so if like just sketch it out at the side here. Originally, this is 0, 180, 360. Okay, then here is what? 90, 270. Y'all by the end of your IG, right, y'all will draw this at least 1,000 times. Should draw it at least 1,000 times. Okay, Brandon is asking, so sine 3x will intersect at 60, 120. Yes, very good. You're right. Because all your angles will be divided by 3. Very, very good. Okay, so what Brandon is mentioning, so sine 3x How do you know where is the point of intersection? Okay, all your angles, the main angles. So the main angles you just need to memorize based on your original one was 180 degrees. Okay, 180 degrees divided by 3. So that will be your first, the original middle point. Your 180 divided by 3, then 360 divided by 3. Then your next cycle. Okay? Okay, let's draw the y equals to 1 plus cos 2x graph. So they put the 1 in front. It doesn't matter, you can just shift it to the back. Cos 2x plus 1 or 1 plus cos 2x is the exact same meaning. So cos 2x plus 1, two things going on here. Number one is the period. Okay, so I am fitting 2 cycles in 360 degrees because now my period is 180 degrees. Then, after I finish that already, I shift the entire graph up by 1. Okay, so you see, so this when I was a student, even when I went to college, this is actually what I normally do. I always sketch it out first. Okay, the original graph. You don't want to count everything in your head because this one you're sketching things, you know. Sorry, this is y equals to cos x. Okay, so you need to know how the original graph looks like first. Don't have to be very, very nice, the sketching one, this one is for your own reference only. So now what you want to do, okay, you get the main points, 180, 90, 270, 360. Okay, now cos 2x means I want to fit 2 cycles in 360 degrees. 2 cycles of cos graph within 360 degrees, right? Okay, so what will happen here is all your angles also will be divided by 2. Okay, so you just need to follow only the period divide by 2. So all your angles also divide by 2 lor. Okay, so now I become like this. Okay, this is your y equals to cos 2x. Okay, then your ending point is 360 degrees. What happens to all your other points also? All divide by 2. Okay, so we can say here, this one is, it basically is your original graph, the intervals are, so the main points are for your 0, maximum point, minimum point, and all is intervals on 90 degrees. So if you 2x, everything is divided by 2. So now your intervals will be 45 degrees to show all your significant points. So you see the first time, it intersect will be 45, then 90. Okay, very hard to see here. Okay. So yeah, practice doing like this. Then y equals cos 2x plus 1 means my entire graph shift up by 1. Okay, so my 1 will become 2, my 0 will become 1, and then my negative 1 will become 0. That's the logic behind. Okay, so here. Okay, I'll just sketch it out here. So your now will be 2. Your principal axis for the y equals to cos 2x will be 1. Okay, this is y equals to 1. Okay, so like this. So let's see what are the main points are. Over here, over here, over here, and go up. Over here. Wait, let me see. And go up. And go down again. Okay, wait. Okay, so you see here's the middle. Okay, then I need to draw another cos graph. Let me see, where are the main points again? here, here. Okay, like this. Okay, so this is my y equals to cos 2x plus 1 graph. Main thing, you all need to practice a lot of the graphs, okay, on how to sketch it. This part here is not easy, okay. I think most students struggle with actually sketching this graph. So if at the start here right now you all don't get it, it's totally normal. But make sure you all practice it based on the principles that I'm teaching you all, your A, B, and C. Just keep repeating it, A, B, and C, A, B, and C. How does it affect? Then you just need to sketch a lot of graph. Okay, so main thing here, what they are, okay, so now we did question A already. Question B, state the number of roots of the equation. Y, okay, no Y, they straight away put sine 2x equals to 1 plus cos 2x. Okay, you all need to recognize this equation. What are they actually doing here? Sine 2x equals to 1 plus cos 2x for 0 degrees to 360 degrees. They are not asking you to state the roots, but just state the number of roots. Okay, read the sentence carefully. State the number of roots. State the number of roots means just number. How many? 1, 2, 3. How many solutions are there? All right. But the thing to recognize is this equation. Sine 2x equals to 1 plus cos 2x. Basically, what is happening here, if you all observe, this is actually your sine graph, the green color graph for the equation. And here is your orange equation. So this is, in a way, y1. Okay, y1 equals to y2. What do we learn about this? Okay, this is actually a simultaneous equation. We substitute both y's together. It can be a line, it can be a curve, it can be a trigo graph. As long as you sub one equation to another equation in mathematics, that is what we've been finding it. In fact, actually, this is what we learn since you all learn mathematics. Okay, the first time you all encounter mathematics, the solution of it, we're actually always subbing one to another to find an answer, all right, to the problem that we are trying to solve. Normally, it's the relationship between two parties. Okay, so y1 equals to y2, number of solution. So all we need to do, we are not supposed to count it. All we need to do is find the point of intersection. That is the roots. Okay, roots, the other meaning is solution. So you see here, 1, 2, 3, 4. And see? Okay. Why I say this one we need graph to draw also, because sometimes when we draw that time may not be accurate. Okay, if we just roughly sketch only may not be accurate. So we need a proper graph paper actually to draw it. What if I draw, like, imagine your this side here, the orange color line, maybe you draw a bit higher. So won't be accurate already. Okay? So for the answer for this, after you count it already, you just need to write number of roots is equals to 4. Okay, number of roots for this equation that they're trying to solve is 4. Sorry, I'm having a bit of cough. Okay, cool. Any question? Any question for based on this? Okay, okay, so I will require you all to practice exercise 9.4. Okay, exercise 9.4. There is no shortcut for this, so you all really need to do it. Okay, do we have time for? Okay, I think let's finish up the graph. Turn to 9.5. Okay, page 205. This is graphs of y equals to modulus fx, where fx is a trigo function. Okay, this one you all can do also. This one will be simple. It's basically you all need to know how to do the 9.4 first. Then this one you just flip the whole thing up. Okay, you all remember modulus, right? Modulus concept, exactly the same one. Okay, for any kind of equations. Any kind of equations. Okay, let's look at work example 8 first. So, let me highlight this. Sketch the graph fx equals to modulus sine x for 0 to 2 pi. Okay, you all need to take note of this range. Don't neglect it because later on the further questions also, yeah, you all need to take note of it. Don't always assume that it's just 0 to 360 degrees. Okay, so now they say sketch the graph, right? What I will do, I will normally draw the original graph first. Same concept of how I taught you all for like straight line, for quadratic, cubic. Okay, when you want a modulus, the textbook style of it might teach differently, like they straight away give you the value with the modulus. But I always encourage students to just draw the original graph first. So at least you won't be confused with the negative or positive values. Okay, so you sketch it out, like your original one is like this, okay, modulus, whatever is negative will go to positive. Okay, so your down here will be gone, then you'll go up here. So it's like your McDonald's like that. Okay, M shape. Okay, so oh wait, actually this book or this example got right, the original one. Okay, so you see the dotted line one, that's your original graph, right? Okay, draw your original one first. You see the range, sometimes they will express it in degree, sometimes in radian. So you just follow. Okay, so get familiar with both of it. 0, pi, 2 pi. Then in between, pi over 2 and 3 pi over 2. Okay, your original graph, 1 and -1. So these are your main points. As you can see here, I always put like an X or so to state all the main points first. Over here, over here. So your original graph is original sine graph, something like this. Okay, this is your original sine graph. What a modulus will do, it will flip it up. So whatever that is negative will become positive. So now, like this. Okay, so this will be your y equals to modulus sine x graph. This is y equals to sine x. Okay, we just need to reflect in the x-axis. What we are doing here, reflect in the x-axis for the part that is below the graph, the part that's below the graph. Okay. They gave you your domain is from 0 to 2 pi. You look at question B. Now they say state the range of the function f. We go back to chapter 1. What is the definition of range? Range. What's the definition of range? You remember? I think in exam we did it before, right? Domain and range. So range is your smallest and your biggest y value. Okay, when we use the word range of f, we are referring to the y value, never the x value, unless they say the range of x, but I don't think they normally use that language. They will normally use just domain. So you have to observe now, based on your new graph, y equals to modulus sine x, where exactly is your lowest point and your highest point? The lowest point is 0, okay, because no more -1. And your highest point is at pi over 2 and 3 pi over 2, which is 1. So your range will now be 0 to 1. Okay, 0 to 1. Not from -1 to 1 anymore, that was your original y equals to sine x graph. Okay, this was work example 8, page 205. Okay, let's move on. Last one. Okay, last one. Work example 9, page 206. On the same grid, sketch the graph y equals to modulus sine 2x and y equals to cos x for 0 to 360 degrees. Okay, two things here. Y equals to modulus sine 2x and y equals to cos x. Okay, sketch it out first. Once again, this one you might need to draw it as accurate as you can. Okay, 0. What do I do here? 180, 360 degrees, and 90, 70 degrees. Okay, let's draw the y equals sine 2x first. Sine 2x means now your period will be 180 degrees, and I'm fitting 2 cycles of sine graph within 360 degrees. Okay? Anything else? Okay, just sine 2x itself. So right now, it looks something like this. Okay, wait. Okay, this is my original one. Probably a bit lower. 1 and okay. This is y equals to sine 2x, but if we modulus it, then whole thing goes up. Clear? This is how your y equals to modulus sine 2x graph looks like. Always draw your original one first, so you can sketch it at the side. And y equals to cos 2x. Okay, so just draw your normal cos graph, so which is here, here. The minimum point is 180, 270, 360. Okay, so like this, like this, like this. Okay, y equals to cos x. Now, what do you want to do? Okay, everyone clear how to draw this? Okay, practice later. Now, state the number of roots of the equation y. No, they never even write y. Modulus sine 2x equals to cos x for 0 degrees to 360 degrees. Okay, for this question also, you need to take note of the domain of x that they are giving you. Sometimes they may just say, oh, use half the graph. Then you just need to look at half the graph and the number of solutions. Okay, so please take note of that. So you look over here. Now, this is also y1. Orange color is, this is y1 equals to y2. Okay, y1 equals to y2. You see? So when y1 equals to y2 means you do simultaneous equation with both equation, which means on a graphical, when we look at it at the graph, is we are wanting to find the point of intersection, which is also known as your number of roots or your solution. So let's see where they intersect. Here, 2, 3, 4. Okay, you see? 1, 2, 3, and 4. So your number of roots for this equation will be equals to 4. Okay, so this is actually the same type of questions based on 9.4, just that right now we modulus it. So you need to know how to draw the original graph first. Modulus, very simple, just reflect on the x-axis, or your negative will go to positive. Okay? Who? Jeff, okay? Practice, huh? All right, so I'll end the recording here. I'll try to upload all of this together as one batch.